So, hello everyone, good evening. So, today we are going to start our discussion on the topic of biopharmaceutics, under which we are going to talk about the absorption. In last class, we have, as I mentioned, have revised your to guys semi-solid dosage forms, suppositories, and the remaining portion of the ointments, etc. So, as I mentioned in the last class, that we have left with the quality control test of the suppositories. So I'm gonna complete that small portion of the quality control test of the suppositories and some giving you some idea about the displacement value. Then we are going to start our discussion on the biopharmaceutics subject. So am I audible? Am I audible to you guys? Is my voice is clear to everyone?
Yes, Praveen, go ahead.
Okay, sir. Great. So 1 minute, let me share my whiteboard with you guys. 1 second, 1 second. So in the last class, I have discussed about the suppositories base. I has also have talked about the different types of suppositories base which have been used, which includes I have talked about the cocoa butter and its different types of polymorph of the cocoa butter, their melting points, which form is more stable. And other than the cocoa butter suppositories base, I have also talked about the other bases also. So I hope so everyone has the visibility of my board, whiteboard. So So today we are going to start our discussion on the quality control test or the evolution of the quality control test of the suppositories base. Suppositories mainly. So first test is simple, which is nothing but the test of appearance, where we physically examine test of appearance, where we physically examine the suppository and look for the any changes in the color, texture, or smoothness, etc. So next, test for dissolution. So do you guys have any idea which dissolution apparatus is used for the dissolution test for the suppositories? Do anyone has any idea which dissolution test is used for the suppositories? I hope you guys able to recall the dissolution apparatus which is used for the testing the dissolution test for the suppositories. So mainly two types of dissolution apparatus are used, which first one includes the suppository dialysis cells, dialysis cell, and the stationary basket apparatus. The stationary basket apparatus. So these two apparatus are used as dissolution apparatus for testing the dissolution of the suppositories. So next, for guys, please mute your mic, guys. Whoever has kept, please mute it. Okay. So next test is the test for the melting range. Test for the melting range. So in test for the melting range, we measure the macro and macro melting range, where we test the two types of melting ranges. First one is the macro and the micron melting range. So for the testing of the macro melting range, which is mainly used to measure the stability. So macro melting range signifies the stability. And do you guys have any idea which apparatus is used to measure the macro melting range of suppositories? Can anyone able to recall it? Can anyone able to recall it? Which apparatus is used for the testing the macro melting range of the suppositories? It is tablet disintegration apparatus. It's tablet disintegration apparatus. And the second one is the micro melting range. So after this, the fourth test which is done is the weight variation test. Can anyone say me the how many number of suppositories should be taken for the weight variation test? For the weight variation test, what is the sample size? I want everyone to answer this question. What is the sample size in the weight variation test? Provide me the sample size for the weight variation test of the tablets. Come on, guys, provide me the answer. Does no one know the answer? So the number of samples taken for the weight variation test are the 20. 20 suppositories are taken and not more than two, not more than two, not more than two should differ from the average weight of more than 5%. And none should differ from the average weight 10%. 10%. Okay. So this is the generally criteria for the weight variation test. The fifth test, which is generally connected, is the test for the softening time. Test for the softening time. So it is basically the test in which we determine the time taken for the glass rod to go through the suppositories and reach the constriction known as softening time or liquefaction time. So basically, we take a glass rod. So let me draw it. So basically, this is the suppository base, and basically we take a glass rod and we try to penetrate into it, and we try to how increase the temperature. So then we determine the how at what time, how much time does the rod is taking to get penetrate into the suppository base. So next one is the test for the so sixth test which is performed is the test for physical strength, or breaking test, which is also known as breaking test. So according to the test, we measure the tensile strength of our suppository braid, tensile strength of the of our by using the breaking test apparatus. So we measure the tensile strength by using breaking strength apparatus. So next test is performed is the content uniformity test. The next test which is performed is the content uniformity test. In content uniformity test, do you guys have any idea what is the sample size or how many suppositories base are taken for the content uniformity test? Do anyone has any idea? Do anyone has any idea what is the sample size or how many suppositories are taken for the content uniformity test? So the sample size is 30. So 30 suppositories are taken for the content uniformity test, and among 30, only 10 are taken for the performing SI. So in SI, what we do is nothing but we estimate the amount of drug present in our suppositories by using a validated method. So this is all about the quality control test of the suppositories. Next, let us talk a small discussion on the displacement value, which is a very important term under the suppositories. So displacement value. So value, the volume of suppositories from a particular mold is uniform, but its weight will vary because the density of the drug usually differ from the density of the base. So generally, the suppositories base which we have used in the preparation of suppositories has its own density, and the drug which we incorporate in the suppositories base also have its own density. So whenever we try to incorporate drug into the suppositories base, there will be lead to displacement of the sum of the suppositories base. So that amount of suppositories base that is displaced by the addition of drug, it is known as displacement value. So it is also represented as the number of parts of drug that displaces one part of one part by weight of the base. So basically, let me explain you this by a diagram. So for example, this is a suppository base. So whenever we try to add a drug into the suppository base, it will get, so it will like in this thing. So the drug will try to displace the drug will try to displace the suppository base. So how much suppository base is displaced by the how many parts of drug? So this is basically known as the displacement value. So there are particular displacement value for the each of the drug. For example, let me aminophylline. The drug aminophylline has a displacement value of 1.5. The castor oil, the castor oil has the value of 1, and zinc oxide has the value of 5. So these are the different values of the suppository base. So whenever we try to calculate the amount of drug or the amount of suppositories base required for the manufacturing of the suppositories, so we have to consider the suppositories displacement value of the drug, then only by which we can take the accurate amount of drug and the suppositories base. So these have to be kept in the mind, guys. So next, so this is all about the suppositories. So do anyone has any doubt up to now? Do anyone has any doubts up to the quality control test, the displacement value, etc.? So another important thing which I think should be discussed is the glycerol-gelatin base. So while coming to the glycerol-gelatin base, glycer glycer glycerol-gelatin base, gelatin base, which is generally nothing but the mixture of glycerol and gelatin. So basically, according to different pharmacopoeias, the ratio of the glycerol and the gelatin get varies. So here we have to remember the main. According to British Pharmacopoeia BP, the glycerol is 70 percentage, while the gelatin is 14 percentage. While coming to the USP, the values are 70 percentage and gelatin content is 17 percentage. So I think this is, I think, clear, guys. And mainly, as I mentioned in the last class also, the glycerol gelatin base is mainly used in the vaginal suppositories, mainly used in the vaginal suppositories for prolonged action, for prolonged action. So I think so. This is clear to everyone, you guys. So do anyone has any doubts related to the suppositories, quality control test, displacement value? If there are no doubts, then let us move to our next discussion of the uh, biopharmaceutics, where we are going to talk about the absorption. So let me share a screen with you guys. So I hope screen is visible to everyone. So basically, so biopharmaceutics is also one of the important subject while coming to the GPAT and NIPER, and approximately 10 questions. We can expect the 10 questions from the biopharmaceutics. And the biopharmaceutics mainly starts with the introduction of the ADME, then followed by the compartment analysis and clearance. So while we talk about the absorption, so what is meant by the so before whenever a drug is administered via the GIT route, the fate of the GIT route is this is how it look like. So mainly it consists of the three phases, which include the pharmaceutical phase, the pharmacokinetic phase, and pharmacodynamic phase. So basically, what it indicates the pharmaceutical phase. Pharmaceutical phase then include nothing but the formulation of dosage form and the release of the drug from the dosage form. So that's what up to the pharmaceutical phase comes into the action. After completion of the pharmaceutical phase, when the drug gets soluble in the GI fluids, then it gets absorbed via the GI enterocytes which are present in our small intestine and then enter into the blood. So after absorption nothing but movement of the drug from the route of administration to the systemic circulation. So can anyone say me how much percentage of absorption occurs when the drug administered via the IV? What is percentage of absorption when the drug is administered via IV? Come on, guys. 100%. Great, guys. Great. So, because generally, in whenever we administer the drug via IV, there is no actually there is no perfect or so-called step of the absorption. The drug directly enter into the systemic circulation. So, next pharmacokinetic phase, which is also known as ADME phase. The ADME has been expanded to ADMET, where the T extra indicates the toxicology. So basically, after entering into the systemic circulation, which is typically the blood, the drug binds to the plasma proteins and also it flows to the different organs where it gets metabolized mainly in the liver. And after metabolism, main aim is to convert the lipophilic drug into hydrophilic drug. So metabolism is nothing but the defense mechanism of our body to eliminate the foreign substances from the body by making them more water soluble. So basically, can anyone say me how many phases of drug metabolism? How many phases of drug metabolism are present in our body? Can anyone say me how many phases? Actually, there are three phases of metabolism. Actually, there are three phases. So, phase one, phase two, you guys have been known from this since long time. But when you try to have the more research on the metabolism, there is also a phase three metabolism where the comes the action of the PGP, which is nothing PGP. Do you guys have any idea about the PGP? Do anyone have any idea about the PGP? Do anyone have any idea about the what is meant by PGP? Let me elaborate more it. P glycoprotein. So do you guys have any idea about the P glycoprotein? So P glycoprotein comes is nothing but a efflux transporter which is present throughout our body, mainly in our intestine and blood-brain barrier. So basically, what does a P glycoprotein do? So, for example, this is a barrier through which our drug must cross to enter into the systemic circulation. But there are certain types of transporters are present in that barrier through which whenever the drug binds to these barriers, it again efflux into the lumen rather than entering into the blood. So these are nothing but the efflux transporter, and the most classical example of the efflux transporter is the glycoprotein. So next excretion. So excretion, nothing but the termination of action of our drug and elimination from the body. So mainly excretion occurs from the kidney. It can also occur into the fecal matter, and sometimes it can also occur to the milk, sweat, etc. So can anyone say me what properties of the drug leads to the excretion from the fecal matter? I think guys you have to mute your mic. So in what properties of the drugs enables its excretion from the fecal matter or through bile? I have elaborated. I have more considered the question. In what properties the drug must possess so that it can be eliminated or excreted through fecal matter? Come on, guys, answer my question. Answer my question. And I also have given a hint of bile. So polar non-anionic. Okay. So bile. Okay, high molecular weight. Great, great, guys. So bile basically interacts with the lipophilic molecules. So basically, bile has a main role in the lipophilic molecules. So whenever highly lipophilic drugs enter into the body, the majority of the portion maybe get eliminated via the fecal matter. So next,
So depending upon the depending upon the type, it can be occur. It can also have the therapeutic effect, or they maybe have the toxic effects. So this is the more elaborated way where the first by using the drug excipient we formulate the dosage form. Then from the dosage form, the drug get released into the systemic into the
next after absorption, so drug in dosage form, if drug is not released, so basically, so there are many challenges that are associated whenever we administer a drug via oral dosage form. Because first, the drug must get released from the dosage form, then it may get solubilized. After getting solubilized, it should have the sufficient lipophilicity so that it can able to permeate through the enterocyte or the intestinal wall. So the difficulties, whatever are faced, we're going to discuss in the upcoming sessions. So as I mentioned, there is a drug release and drug dissolution. Then the drug enters into systemic circulation. Then after in systemic circulation, to enter into the tissue, it gets distributed to the tissue of this tissue or desired tissue and also the non-desired tissue. So whenever the drug interacts with the non-desired receptor, it leads to toxic effects or any adverse effect. Next, drug distribution and elimination. So metabolism and excretion. So the distribution and elimination are togetherly known as disposition. So you have to remember, you guys, the distribution plus elimination is totally known as disposition. Next, pharmacological response, therapeutic or toxic effects. So let us talk our discussion one by one. So, Semi, is the distribution is a reversible phenomena, irreversible phenomena? Is the distribution is reversible or irreversible phenomena? Great, guys. Yes, the distribution is a reversible form phenomena. It generally it occurs the transfer between the blood and the tissues. So it is a reversible phenomena. So now let us talk about the absorption. Absorption is nothing but, as I mentioned, the process of movement of unchanged drug, unchanged form of drug from the site of administration to the systemic circulation. So there always exists a correlation between the plasma concentration of the drug, the therapeutic response, and thus the absorption can also be defined as the process of movement of unchanged form of the cytoadministration. So basically this is the plasma drug concentration curve where in x-axis we plot the time, in y-axis we plot the plasma drug concentration. So basically here we have the two values. So it is nothing but the minimum, this is the minimum effective concentration, and this is the maximum safer concentration, MEC by MSC. So tell me, guys, what happens when my drug concentration is below minimum effective concentration? What happens when my drug concentration is below minimum effective concentration? Do I can able to see any therapeutic response? Yeah, great, guys, great. So here, so minimum the drug concentration should be above minimum effective concentration, but it should be below the maximum safer concentration because, yeah, no therapeutic response. So whenever the drug concentration gets spiked above the maximum safer concentration, it leads to toxic effect. So there is something known as therapeutic window. In between the therapeutic window, the drug concentration must be maintained throughout the half-life of the drug in order to have the desired effect. So next, uh, so when we talk about the absorption, we have to certainly talk about the intestinal barrier which is present in our body, mainly in the GIT. So basically, this is how a broad overview of the pictorial diagram that how our intestinal membrane look like. So basically, it consists of the bilipids, proteins, protein molecules, and you have to all know. Can anyone say me which charge that the membrane possesses? What is the charge of the membrane? Come on, guys, answer my question. What is the charge on the membrane? Answer my question. This membrane, the intestinal membrane or the GIT barrier, possesses which charge? Positive charge, negative charge, neutral, or it possesses both positive and negative. So here comes the question. Yeah, negative charge. Great, guys. It possesses the negative charge and it celiac acid. Due to presence of the celiac acid, it consists of the negative charge. So basically, this is the whole description of the membrane, which I have mentioned. It's made up of the phospholipids, made up of the bilayer, which contains the both hydrophilic and hydrophobic molecules, hydrophilic, hydrophilic head, hydrophobic tail, and the proteins are also present in the cell membrane. So basically, the proteins act as the transporters, which helps in the transport of different molecules from the GIT to the blood. So basically, the fluid mosaic model has been given for our cell membrane. So we generally indicate that our cell membrane is semi-permeable, which means it is selectively permeable to only certain kind of drugs or the molecules, but it's not permeable to the certain kind of molecules. So it controls what enters in what exists into the systemic circulation. It protects the internal environment and exposure of the harmful materials to come into the systemic circulation. And also it is allow the communication between cell to cell. So between cell to cell communication, it is flexible and movable. It is generally mixture of phospholipids, etc. So this is the broad overview of the different mechanisms of drug absorption by which a drug is absorbed from the GI barrier into the systemic circulation. So basically, what is meant by the transcellular? Come on, guys, answer me. What is meant by the transcellular transport? So what is meant by the transcellular? What does the word transcellular signifies? What does the transcellular transport signify, guys? Come on, answer my question. Do you guys have any idea about the transcellular through GI wall? Yeah, through basically through cell. So let us consider this as a cell and this as a cell. So basically, the transport of a molecule through the cell is nothing but the transcellular. If the transportation occurs between the gap junction which is present between the cell, it is nothing but the paracellular. So this is basically the difference between the transcellular and paracellular. And also there can be another type of transportation where the inside the cell the vesicles are formed, and by this vesicle the drug is transported to the other side of the cell. So basically the transcellular or intra, as you can see, as the intra signifies something through the cell, and inter signifies something between the cells. So transcellular, so basically this is the main two types, passive and active. So passive, as the name signifies, there is no utilization of the energy. So if there is no utilization of the energy, then what is the driving force for the passive diffusion? Answer me, guys. What is the driving force by which the passive diffusion occurs? And also I have to, and you also have to say me the which law is applicable for the passive diffusion. Concentration gradient, great. And which law is applicable for the passive diffusion? Fick's law, Fick's, yeah, great guys, great. And for the pore transport, what is the driving force for the transportation? For the pore transportation. Answer me, guys. What is the force which leads to the port transportation? Come on, guys. Revise your thoughts. Revise your concept. Yeah, great. Hydrostatic pressure. Great, 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 great. And for the facilitated or carrier mediated diffusion, basically the carriers are involved. And here also, based upon the concentration gradient only, the facilitated transportation occurs, but without utilizing the energy. So while coming to the active transport, so guys, say me what is the main difference between the primary and secondary active transport? Come on, guys, answer my question. Why there is a special classification? What is the difference between the primary and secondary active transport? Come on, guys, answer my question. Why there is a special classification? What is meant by the primary active transport process? Do you guys have any idea? Primary needs direct ATP requirements. Okay, great, great, Harshali. Yeah, ATP. Yeah, both require ATP, but in primary, only one molecule is primary generates energy and secondary utilizes previously generated energy. Okay, Vivek. Okay, great. So basically, in primary, only one molecule is transported at a time, and the energy required is also the same. While coming to the secondary, the two molecules are transported maybe in the same direction, maybe in the opposite direction, but the energy is utilized for the transportation of only one molecule. So this is basically next paracellular, as I mentioned, permeation to the tight junction and persorption. And the third one is the vesicular transport, which includes the pinocytosis and phagocytosis. So what is difference between the phagocytosis and pinocytosis? Come on, guys, say me. What is difference between the pinocytosis and the phagocytosis? What is the main difference? Cell eating and cell drinking. Which is cell eating and which is cell drinking? Which is cell eating and which is cell drinking? Pino drinking. Okay. So phago eating. Pino cells drinking. Great, guys. Great, 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 great. So do you guys have any idea by which transportation the polio vaccine is get transported? I think this is the question of the GPAT 2019. By which transportation the polio vaccine, Sabin polio vaccine, OPV, polio vaccine, polio vaccine is transported by which mechanism? Sabin oral polio vaccine, which is a live attenuated, is transported by which mechanism? Pinocytosis or phagocytosis? Transcytosis. I'm talking about the polio. It is pinocytosis. It's not phagocytosis. Pinocytosis. So this is the basically overview where we can see that the passive diffusion is the concentrated gradient, and it can be both passive diffusion and the carrier mediated transport are the transcellular. Paracellular transport between the tight junction. Vesicular transport is nothing but the formation of vesicles in in the cell. This vesicle transport the drug across the cell. So basically the two sides we have seen, the apical side and the basolateral side. So basically B. So B for blood. So which side, whatever the side the drug is present, it is known as basolateral side, and the opposite side is nothing but known as apical side. The apical side is also known as luminal side or mucosal side. So this is I have also discussion about this, that permeation to GI cell epithelial membrane, movement across the intracellular space of cytosol. Next, as I mentioned, the passive transport, so passive diffusion. So diffusion is nothing but movement of molecules from the high to low concentration. So as I mentioned that here the concentration is range is high and here the concentration range is low. So molecule will try to diffuse in all directions in order to maintain the equilibrium. Guys, in the GIT, During diffusion, does the equilibrium is maintained? In our GIT, whenever a drug absorption occurs, does the GI equilibrium is maintained? Think about it, guys. Because the passive diffusion gets stopped whenever the equilibrium is attained. In our GIT, does the equilibrium attains? Yes, yeah, great. Never ever the equilibrium conditions are attained in our GIT because the blood flow continuously throughout the body and it leads to formation of the sink condition. This is what the terminology sink condition. This due to the presence of the sink condition, the concentration gradient get established and which act as the driving force for the drug absorption through the GI membrane. So these are the small concepts which have to be clear, guys. So as I mentioned, the passive diffusion, 90% of the drugs which are the administered to the in our body are absorbed by the passive diffusion. So basically, diffusion is nothing but the when the drug concentration from the one side is higher than that of the other side. So process is passive, no external energy is expanded. Driving force is mentioned as the concentration gradient which is present on the both sides. So this is the basically schematic diagram that how it occurs. So basically, it depends upon the fixed law of diffusion, which is given by dq by dt is equal to dA, where d is the nothing but the diffusion coefficient of the drug, which is the molecular property of a drug, and it get different from the drug to drug, where A is the surface area, K m by W is the K m by W, C GIT nothing but the concentration in the GIT, concentration in the blood, H is nothing but the thickness of the membrane. Guys, that the H value changes. Is the H value is constant or it is variable? The thickness of the GI membrane is constant value or it is variable value? Can anyone answer my question? Is the thickness of the GIT is a constant value or a variable value? Is it variable? The thickness of the GIT remains constant. It remains constant. It remains constant. So So these are the different parameters. So as I mentioned that if the diffusion coefficient increases, the diffusion increases, the surface area increases. These are all the directly proportional, and this is the inversely proportional. So as I mentioned, the CGIT is always greater than the C. That's why which leads to the sink condition. So as I mentioned, Km by W is the partition coefficient. So as the partition coefficient increases, the diffusion also increases. Provide me one thing, guys. For example, I am increasing the log P of log P of a drug. If I'm increasing log P and the permeation rate, I am checking the log P and the permeation rate. Permeation rate relationship is the relationship between the log P, which is nothing but the partition coefficient permeation, is the linear or it is U-shaped? Come on, guys, answer to my question. Is the relationship between the log P and the permeation is the linear or it is U-shaped? Is the relationship between the partition coefficient or lipophilicity and permeation is the linear or it is U-shaped? Come on, guys, answer to my question. Try to use your concept, guys. These are the very simple questions, and this year the GPAT question paper will be full conceptual one. So try to clear your concept. Is the What is the relationship between the log P and the permeation? It is not linear. It is the U shape. At a particular log P, the permeation increases, but so I know as well you have known about the Lipinski rule, where you can Okay, and I also mentioned that the CGIT is always the C, so that's why it leads to the syn condition. So syn condition, as I mentioned, so I have also mentioned CC syn condition. Next, permeability. So basically, it is the first order process. So it is directly proportional to the concentrated gradient. It is greater the surface area, lesser the thickness, faster the diffusion. These also have mentioned, etc. Uh, Let me frame a question here. For example, a drug is getting absorbed via passive diffusion. Diffusion. The diffusion is will be affected by metabolic poisons, uh, the toxins, mm, see both the no effect. Answer to this question, guys. My drug is getting absorbed. Yeah, great, guys, great. So there will be no effect on the diffusion because diffusion is energy independent. That's why the toxins and the metabolic poisons have the no effect on the drug diffusion. So here comes the characteristics are the greater the partition coefficient, faster the absorption, the unionized species. Why does the unionized species have the greater diffusion when compared to the ionized species? Answer my question, guys. Why the unionized species have the faster diffusion when compared to the ionized species? What special characteristics does the unionized species possess so that which makes them the having the greater diffusion? Can anyone answer to my question? Guys, you have to be quick. You have to be quick because by which it leads to the clearance of your concept. They are lipophilic. Great. That's why they have the 3 to 4 times more transportation. So diffusion is rapid when the volume of the GIT fluid dilution decreases the concentration, hence diffusion usually in treatment of overdose and poisoning. So it is not inhibited by the metabolic poisons depending upon the. So this is all the further example between basically the molecular weight of the drug is between the 100 to 400 daltons. Exception is the cyclosporine here. Since it have the molecular weight of 1200 is absorbed by the passive diffusion only. So next one is the pore transportation, which is also known as filtration, bulk flow, convection transportation. The driving force is basically, as I mentioned, asked earlier, which is the hydrostatic pressure or the osmotic difference along the membrane. Basically, the small hydrophilic molecules are absorbed through pore transportation, basically the linear molecules, and along with the water, the molecules are dragged to enter into the systemic circulation. Generally, the aqueous pores are present. So, what is the diameter of that aqueous pore? It is the question asked in the GPAT 2020. What is the aqueous pore diameter? Can anyone able to recall? If anyone has solved the PYQ, then I'm able to answer this question. What is the diameter of that aqueous pore through which the pore transportation occurs? It is basically, come on guys, I think you guys have to revise. It is basically between 4 to 10 angstroms. So drug permeation to the water filled channels, it is important for the and removal for the drug from the cellular spinal fluid. So this is basically the order. The unionized molecules, there's anions, then cations. Next, ion pair transportation. So ion pair, nothing but this based upon the electrostatic interaction between the electrostatic interaction by which the absorption occurs mainly for the quaternary ammonium compounds like benzalkonium chloride, benzethonium chloride, and sulfonic acid. So, what is the use of the benzalkonium chloride as an excipient? Do we use pharmaceutically benzalkonium chloride as an excipient? What is its role? Yeah, great. Preservative. Yes, yes, preservative. Great, guys. So basically, this compound get ionizes at the all pH, by which these are the prone to the ion pair transport. So despite their low partition coefficient values, such agents penetrate the membrane by forming the reversible neutral complexes with the endogenous. So basically, so these compounds, for example, these are the negative charge, these are the positive charge. These both form a complex. These both form a complex. The complex penetrates to the membrane where they both get dissociated, negative and positive. The negative drug get absorbed into systemic circulation and the positive ion comes again. So by this mechanism, the unpaired transportation occurs. So this is, as you can see, cationic drug, endogenous anion form neutral ion pair transport, get passive diffusion, etc. Next, carrier mediated transport. So carrier mediated transport, some of the polar drugs cross the membrane more readily than can be predicted from the concentration gradient. The partition coefficient like monosaccharide, amino acids, and vitamins will be poorly absorbing. So basically, for the monosaccharides, amino acids, and vitamins, basically the transport mechanism which is available in our GIT is the carrier mediated transport, where the specifically a carrier or carrier is nothing but which is made up of the protein which are present in the membrane, the phospholipid bilayer membrane, and the carrier, the drug binds to the carrier and get transported through the GIT membrane. So basically, it consists of a carrier. So carrier look like this way. So carrier basically provide a tunnel for the transport of the drug into the systemic circulation. So mechanism is involved is carrier is bind reversible non-covalent to the solute to the transport. Why there is a non-covalent binding? What happens when the covalent binding occurs? Generally, whenever a drug get transported via carrier transportation, there is a non-covalent binding. Why there is a not a covalent binding? What happens when there is a covalent binding with the carrier? Is the transportation is possible? Covalent bond is a strong bond, yes, by which the drug was can't able to get removed from the carrier and it cannot get transported. Great, guys. Non-covalent examples. Do you guys have able to recall the examples of the non-covalent bonds? Basically, which are Van der Waals, etc. So dissociation, these are the molecule. So then the carrier returns to its original state to complete the cycle and accept the fresh molecules. So basically, this is the whole how the mechanism of the carrier mediated transport. So characteristics of the carrier. The carrier protein always has a uncharged outer surface and allow it to be soluble with the lipidic membrane. Carrier has no directionality, work with the same efficiency in both direction. So it is not like that the carrier when transporting the drug will work in the more efficiency while coming as a single carrier will come slowly. While transporting the drug and coming again, it has the same efficiency. So is this transportation is saturable? Is the carrier mediated transport is saturable? Answer to me, guys. Is the carrier mediated transport is saturable or non-saturable? Is the carrier mediated transport is saturable or non-saturable? I think everyone must answer this simple question. Is the carrier mediated transport is saturable or not? It is saturable and it has the, yes, great. So it has the competitive scenario also. If something process getting saturable, then those kind of pharmacokinetics are known as linear or non-linear pharmacokinetics. If any pharmacokinetics are getting saturable, then those are known as linear pharmacokinetics or non-linear pharmacokinetics. Those are basically known as non-linear pharmacokinetics. So that's why non-linear. Great, Chintu. So non-linear pharmacokinetics, which is also known as saturable, saturable pharmacokinetics. Non-linear pharmacokinetics. Yeah, non-linear pharmacokinetics. So this is basically to the passive diffusion comes under the linear pharmacokinetics, where the concentration of the drug at the absorption increases, the rate of drug absorption also increases. But for the carrier mediated transport, as the concentration increases, rate of absorption increases. But at a particular time, when the number of carriers present in the GIT gets saturated with the drug, so further addition of the drug has the no carrier to get transported across the membrane, which leads to saturation. So facilitated transport is basically the downhill transport, and the same. The driving force for the passive diffusion and the facilitated diffusion remains the same, which is nothing but the concentration gradient, and no energy is required. Next, while coming to the active transport, is basically uphill transport. So basically, whenever we try to climb the hill, we require more energy. But while coming from the down to hill, by sliding we can come down where we don't require any kind of energy. So basically here the concept come of uphill and downhill transportation. So it can be primary and secondary. And primary, as I mentioned earlier, it is process only direct ATP required more process only transfer one ion or molecule only in one direction, hence the uniporter. Example, absorption of glucose and proton pump. And also it is of two types, organic anionic transporter and organic cationic transporter. The substrate for the organic anionic transporter is the atorvastatin, and for the organic cationic transporter is the diphenhydramine. So another one is the ABC binding protein, which is P-glycoprotein. So secondary anion transporter, as I mentioned, that the two molecules are transported at a time, but the only one energy required. So energy required for the transport of the one molecule is utilized by the transport of the another molecule. So in this process, there is no direct requirement of the ATP. It takes the advantages of the previously existing concentration gradient. The energy required in the transportation of the ion aids the transport of another molecule. So it is also known as co-transport, coupled transport. So basically, two molecules transport together. For example, sodium glucose transporter and sodium ion and proton ion transporter. So basically, this is whole antipode, unipode. Antipode is nothing but the movement in the object. If one molecule move like this, another molecule will move like that. Sympode is both will move in same direction. So passage of the drug, as I mentioned, these were two methods. So this is all basically you guys have known that endocytosis, cytocytosis, etc. Active transport, have pill transporter, faster energy required, inhibited by metabolic poisons. Downhill transporter, slower energy required, not inhibited specificity compounds. Saturable specific, mixed order kinetics. So basically, nonlinear kinetics is also known as mixed order kinetics because initially it follows the first order, and after saturation follows the zero order. So basically, two types of order kinetics are followed. That's why it's also known as mixed order kinetics. So these are the overview. Next, while coming to the paracellular transport, as I mentioned, the paracellular transporter is nothing but the intercellular transport, which is nothing but the transport of molecules through the gap junction which is present between the cell. So first one, persorption is the permission of drug to the temporary opening formed by the shedding of the two neighboring cell. So basically, for example, these are the two cells. So this is the gap. For example, due to some of the damages in the GI membrane, there can be lead to the primary shedding of the cell, or the cell has been lost, which creates a gap. Through the gap, if the drug transportation occurs, then it is known as persorption. Next, vesicular transport. The vesicular transport comes under the category of the active transport. So endocytosis, so large particles are transported into cell by endocytosis. It's also known as vesicular transport. ATP is required. Generally, it is used for the absorption of the vitamin A, D, K peptides in the newborns. So endocytosis occurs in two ways: pinocytosis and phagocytosis. Pino, it means the cell eating, and phago means the cell eating, and pino means the cell drinking. So basically, this is the how the basically first the molecule comes, it interacts with the bilayer, then the bilayer gets wrapped around the molecule transferred to the cytosol, then the molecule get expelled into the blood.
మా క్లాసు
So basically, exocytosis. So exocytosis is a durable energy consuming process by which the cell directs the contents secreted out of the cell membrane. So endocytosis, exocytosis. So exocytosis is nothing but the something removing from the cell. So this is the summary of the whole. The drugs are hydrophobic, molecular weight between the 400 to 100 to 400 are transported via the passively, and the botulinum toxin and the oral polio vaccine both are transported via the pinocytosis. So these have to be clear to you guys. Next, hydrophilic and molecular weight less than 100 are transported by the 4 transport, and the drugs which get ionized at the all pH are absorbed after complexing with the oppositely charged ions through ion pair transporter, where I have mentioned the examples of the benzalkonium chloride and the sulfonic acid. See, carrier mediated transport, which includes the facilitated transport and the active transport, are the substrate specific, by which they only bind to the specific substrate and do not bind to all substrates. So basically, this is all about the absorption, and the macromolecules such as nutrients and drugs, solid particles or oil droplets are absorbed by the endocytosis. So do guys, and you have any doubt regarding the absorption up to now? Do anyone has any doubt? Do anyone has any doubt so that I can move to the next topic? Okay. So now let us move to the some of the important topics like different theories of dissolution, BCS classes, etc. So let me share a wide screen with you guys. So basically, another important classification which is studied in the biopharmaceutics, and it is BCS classification. BCS classification. Can anyone say me the which scientist has provided the BCS classification? Do anyone know the which scientist has given the BCS classification? Okay, so basically the BCS classification was given by Ahmed Ayon. Yeah, great. Ahmed Ayon has given the BCS classification. So basically, based upon the solubility and permeability, the BCS classification is done. So basically, it is class one. Provide me, guys. What are the characteristics of the class one? Characteristics of the class one. Come on, guys. What is the class one of the BCS class? High soluble and high permeable. Great. High soluble and high permeable. Class two. Class two. Low soluble, high permeable. Great, Vivek. Low soluble, high permeable. Class three. Class three, high permeable. Class three, high soluble, low permeable. High soluble, low permeable. Class four, basically both are low. Low soluble, both are low. Okay, great. Both are low. So whenever okay, 1 minute. So whenever these drugs are administered via the GI tract, there is something which is known as rate determining step or the slowest step. So for the BCS class 1 drugs, what would be the rate limiting step or the rate determining step or the slowest step? Answer me, guys. What would be the rate determining steps for the BCS class 1 drugs? Come on, guys, come on. It would be the gastric emptying. For the class 2 drugs, what will be the rate limiting step or rate determining step? Dissolution or solubility, both. Well, let us have a solubility. For class 3, what will be the rate determining step for the slowest step? Permeability. And for the class 4, it will be both solubility and permeability. Both rate determining steps. So basically, the solubility is nothing but the static phenomena, while the dissolution is the dynamic phenomena. So while coming to the theories of dissolution, so the theories of dissolution, specifically three types of theories of dissolutions are given. So basically the first theory is the diffusion, layer model or film theory. So basically, according to this theory, so whenever a particle comes into the contact with the dissolution medium, this particle forms a stagnant layer through surrounding it. The stagnant layer is also known as unstirred layer. So basically, the drug first get dissolved in the stagnant layer, and then the movement of the drug from the stagnant layer to the bulk of the solution is the rate determining step. So, so according to this, the whenever the particle comes in the contact with the dissolution fluid, it basically forms a unstirred water layer or stagnant layer throughout it. So basically, the transport of the molecule from the stagnant layer to the bulk of the solution is the rate determining step. So basically, here we comes the Nernst and Brunner equation, Burner equation. So next theory is the second theory is the Danckwerts model. Danckwerts Danckwerts model or surface renewal theory. So do you guys have any idea about the Danckwerts model? What does that mean by Danckwerts model? Danckwerts model. Do you guys have any idea about the Danckwerts model or the surface renewal theory? So fresh solvent packets always replace the drug packets carrying the drug. Oh, great, great. So basically, what happens is the uh, in the dissolution medium due to the in dissolution medium due to the what are the turbulence, it leads to formation of the solvent pockets. The solvent pockets always travel to the drug particles and carry the drug from the surface. So drug from the surface, after carrying drug from the surface, so the solvent pockets containing drug carries from the surface and go back. So like this, the drug surface always get the fresh solvent pockets by which the dissolution occurs. So the next theory, guys, please mute your mic, guys. Please mute your mic. Interfacial barrier model, which is also known as double barrier model. Double barrier model, or it is also known as limited solvation theory. So which basically depends more upon the solubility, like the drugs which contains the hydrophilic groups or the polar groups interacts more with the solvent which have the more solubility. So basically this series states that. So basically there are the two surface area which are available for the dissolution. Guys, please mute your mic. Please mute your mic, guys. So basically the the two surface area are available which are known as absolute surface area and effective surface area. So basically the absolute surface area is the total surface area of any particle. Whatever the particle, the total surface area processed by the particle is the absolute surface area. And effective surface area is nothing but the area which is exposed to the dissolution medium. So mainly the dissolution mainly depends upon the effective surface area rather than depending upon the absolute surface area. So now, guys, you gonna give me the order of the solubility between the different compounds which I'm going to mention here, between amorphous, metastable, metastable, and stable. So what will be the solubility order between the amorphous, metastable, and stable form, guys? Come on, everyone, guys, answer to this question. Amorphous, metastable, and stable. Okay. Between non-solvents, between hydrates and solvents, between hydrates and solvents, what will be the order of solubility? What would be the order of solubility? Hydrates more. Great, Vivek. Uh, between anhydrous, anhydrous, solvates, and hydrates. Provide me, provide me the order of the solubility between anhydrous, solvates, and hydrates. Basically, between hydrates and solvates, which of the, I think so, you guys have told the wrong answer. Between hydrates and solvates, which of the following will have the more solubility? Between hydrates and solvates? Everyone must answer to my question. Between hydrates and solvates, which will have the more solubility? Everyone answer to my question, guys. Between hydrates and solvates, if we try to compare the solubility, which form will have the more solubility? Solvates, great. And between the solvates will have the more solubility. Basically, why the solvates have the more solubility? Because in hydrates, already in their crystal lattice, the water is get entrapped, by which the interaction with the external water molecules is quite difficult. While coming to the solvates, they have the easy interaction with the water molecules. So while coming to the unhydrates, solvates, and hydrates, provide me the order of solubility, guys. Between the anhydrates, solvates, and hydrates, anhydrates are more than solvates. After solvates, then hydrates. Great, guys. So basically, I will write the order anhydrous. So this is basically that is only audio in which I have mentioned the words that is only the basically order. So another important equation which generally asked in the examinations is the Anderson Hasselbalch equation. Equation which is basically provides the ionization constants, ionization of the weakly acidic and weakly basic. So basically, the 75% drugs which are available in the market are weakly basic, and the 25% and 20% are the weakly acidic, and the 5% drugs are the neutral. So for weakly acidic, it is nothing but pH is equal to pKa by log ionized by unionized. For weakly basic, it is nothing but pH is equal to pKa plus log ionized by unionized. So basically, so for a compound, the ionization coefficient depends upon the two. And ionization of a compound in GIT depends upon two factors. Depends on two factors. Those are the pK of the drug and pH of the surroundings. pH of the surroundings. So these are the two main factors which influences the ionization. So that's why the strong acids and strong bases are completely 100% ionized at the all pH. So that's why the strong acids and strong bases are not used, because these have the zero bioavailability whenever they are administered via the GIT oral mainly route. So that's why the most of the drugs are the weakly acidic and weakly basic. So an important relationship for an acidic drug, ionized, the pH should be less than the drug's pKa. For basic drugs, for maximum unionization, the pH should be greater pK of that base. So this is the basically the values of the pH and the values of the pH and pKa. I'll write it down. So first column which comes between the pH minus pKa. Next, percentage acid ionized, percentage acid ionized. The other one comes with the, let's see, percentage acid ionized or percentage base unionized. The next one is the same reverse, the percentage base ionized or percentage acid unionized. So basically, the difference is 4. Then the value here comes the 99.99. Here it comes the value of 0.01. If the difference is 3, then the value here comes is the 99.9, and the value here comes is the 0.1. If the difference is 2, the value here comes is 99, and here the value comes is the 1. The difference is 1. This table is very important for you guys. There may be presence of any conceptual questions or the calculation where they will provide you the pK of the drug and pH of the solution, and here you have to determine the how. This is to be important, guys. Now for the 0, what would be the values for the both columns? Answer to me, guys. What would be the value of the both? Answer to this question, guys. At the difference of pH minus pK is equal to 0, then what would be the percentage acid ionized and percentage base ionized? What would be the values? Come on, guys, answer. If the pH is equal to pKa, then what would be the percentage of unionization and what will be the percentage of ionization? If the pH is equal to pKa, 50-50. Great, guys, great. So it would be the 50-50. So if the values get negative, then the same one repeats. Nine, and here it will be 91. If it is -2, it would be 1. It would be 99. It would be -3. It would be 0.1. Then it would be 99.9. So basically these are the values, guys. These you have to be remember. So basically the strong acids have generally pK of less than 2.5 and remain ionized at the all pH. And basically these remains the ionized at the all pH, so they are not absorbed via the GI tract, because the ionized form of the drug being more water soluble can't able to permeate the GI membrane. So while coming to the moderately weak acids, where the most of the drugs of our pharmaceutical lies, where they have the pKa between the 2.5 to 7.5, and they are basically unionized in the stomach where the maximum absorption occurs, and they are ionized in the intestine where the absorption do not occur. Mainly the absorption occurs from the stomach. Next it comes the very weak acids. Very weak, greater than 8. So these remains ionized at all pH and absorbed throughout the GIT. So next comes the strong bases. Which have the pK value of greater than 11. Same, these remains the ionized at all pH and they are less weakly absorbed. Next comes the moderately weak bases, where they have the pK 5 to 11, and very weakly pK less than 5. So these are the basic. Do anyone know the what is meant by Lipinski rule? Can anyone tell me the Lipinski rule? Can anyone tell me the Lipinski rule? Lipinski rule. Lipinski rule of 5 or 7 or 8. What is Lipinski rule? How many numbers? It is Lipinski rule of 5. So of 5. Okay, so molecular weight less than 500, great. Next. Molecular weight less than 500, next. One parameter you have guys mentioned, next parameters. So basically, number of hydrogen bond acceptor to 10 and the hydrogen bond donors less than or equal to 5. Lipophilicity of the drug less than or equal to 5. So basically, the Lipinski rule is not a selection criteria. It is basically the screening criteria. So during the drug discovery, when you have the so many molecules in your hand, and in order to get the handful of molecules, you have to screen out the drug. So one of the screening strategy is nothing but the applying the Lipinski rule of the 5. So it is basically the screening strategy. So another important which I have to mention you guys is the rate of dissolution and order of bioavailability. Tablets, I give you capsules, I give you powders, I give you suspensions, emulsions, and solution. Guys, while coming to the solution dosage form, which is nothing but which comes under the category of liquid dosage form, is there any step of the dissolution? For the solution dosage form, is there any step of dissolution? No. So provide me the order of bioavailability to these guys. What would be the order of bioavailability between tablet, capsules, powder, suspensions, emulsions, and solutions? What would be the order of oral bioavailability between tablet, capsules, suspensions, emulsions, and solutions? Emulsion, suspension, capsule, tablets. Okay, great. So while coming to the tablet also, the film, the coated tablets, then enteric coated, then sustained is everything. But so let us have a question to you guys. Gastric emptying is first order, B zero order, C second order kinetics, or D mixed order kinetics. Answer to this question, guys. The gastric emptying, which is nothing but the passage of the drugs from the stomach to the intestine, follow which second order or the mixed order kinetics. Come on, guys, answer to this question fast. First order. Great. It's basically the first order kinetics. And there are the different factors which influences the gastric emptying, which includes the diseased states, drugs. Uh, for example, answer me, guys. Gastric emptying time and gastric emptying rate. So basically, if the gastric emptying rate is faster, then the gastric emptying time will be slower. How? Because if the rate is faster, then in the lower time. So basically, the cholinergic drugs that increases the gastric emptying rate or decreases the gastric emptying rate. The cholinergic drugs increases the gastric emptying rate or decreases the gastric emptying rate. Answer to this question, guys. Increases the gastric emptying rate by increasing the GI mobility so that the contents from the stomach are quickly emptied into the intestine. So basically, for a acidic drug, the gastric emptying rate should be small. Gastric emptying rate should be quicker or it should be slower for acidic drug. Yeah, so that it can get the sufficient time in the stomach so that it can get absorbed. Are also absorbed in the stomach where the mainly the food drug interactions are the most widely occurred interactions where the drug interacts with the food at the various level and it may can increase or decrease the absorption or it may can delay the absorption. So basically the first comes the delayed absorption, the comes the aspirin, diclofenac. So basically all diclofenac, digoxin and paracetamol, PCM. For these kind of foods, the uh, absorption is delayed. Decrease in the absorption, decrease in the absorption, erythromycin, tetracycline, ethanol, and levodopa. Ethanol and levodopa. Increased absorption mainly comes the griseofluvin, mainly the only lipophilic molecules, nitrofurantoin, diazepam, and water soluble. So basically, these are the different types of food drug interaction which are generally used, and generally, and also there can be the pre-systemic metabolism where the drug, the enzymes present in the GI wall can also metabolize the drug and then decrease their oral bioavailability. So, is there any doubt related to this up to now, guys? Do you guys have any doubt up to now? Okay, so I have an MCQ for you guys. So let me. Hmm, so mucin. So do you guys have any idea about the mucin? So mucin is nothing but the mucus layer which is present in our intestine. So mucin and streptomycin absorption increases, absorption same, absorption decreases, free absorption no change, unpredictable. Carefully and then answer to it, guys. Mucin and streptomycin interaction, does the absorption increases, decreases, absorption has no change, or it is completely unpredictable? Answer to this question, guys. Read the question carefully, then answer it. Mucin and streptomycin. Basically, the answer is two. the absorption is decreased because due to interaction between the mucin and streptomycin, which may affect the streptomycin absorption. So another important concept to be remembered is the first pass effect. So which is nothing but the first pass effect. First, basically what it signifies is, so let us consider these as a liver, these as a GIT, so these are the systemic circulation. So whenever a drug molecule absorbed from the GIT basically first enters into the liver where the metabolism occur, which can lead to the loss of the drug. Then it enters in the systemic circulation. So this is known as first pass metabolism where the drug get lost due to biotransformation that occurs into the liver and by which the plasma drug concentration of the drug decreases significantly. So for that kind of drugs which are more prone to the first pass metabolism, for those kind of drugs, the oral route is generally not preferred and the other route of administration is preferred so that the first pass effect can be avoided. So that's it for today, guys. So in next class, we're gonna discuss the other topics which includes the distribution, elimination, etc. So do you guys have any doubt up to now? Do anyone has any doubt? Do anyone has any doubt? Okay. So great, guys. So all the best. Meet you in the next class, guys.